On a previous video, I illustrated the circuit board. Let me bring that drawing up here. Let's see where it'd be right here. Here we go. Okay, where we have a pressure sensor in the well, and it has a current loop sensing, and it goes across this resistor, and the voltage across that is read by an MCP3202 analog to digital converter, which is interfaced to a Raspberry Pi. Well, that Raspberry Pi there's some software that has to, in order to communicate. It's communicating with via SPI. So, and let me just show you the software that actually is doing that. And not only that, though, the Raspberry Pi also has three connections to the main controller board. One, they were meant to be, those inputs were meant to be for float sensors, but I'm not having float sensors. Instead, I'm using a pressure sensor instead, and that so the pressure sensor comes up, goes into this MCP3202, and the Raspberry Pi samples, readings from it, and based on the samples, it actually manipulates the three inputs to the main controller board for the tank high, middle, and low. So if the very high one, top one, is on, for example, that means the tank is full, right? But there's also the Raspberry Pi also deals with hysteresis that for in case because because the readings can vary and so forth. So anyway, let me show you the software now. Okay. So anyway, this is in Python on Raspberry Pi 2W. I'm running it. And the important thing is, as far as getting that inputs from the MCP3202 ADC, is this line right here. Uses a GPIO0. From that library imports the MCP3202. This is the line that brings that capability into it. Now this file does other things, but I'm going to focus only on the part of it that deals with the reading the MCP3202 right now, and toggling the lines going to the main controller. The three lines, one for the representing three sensors, three float switches, frankly, high, medium, and low. So anyway, this is where it actually sets up that interface. It initializes the device, and initializes the MCP3202. It's reading on a differential mode, meaning it's using channel 0 and channel 1 for the input, right? And but this is how you would specify that you're using differential mode. If you didn't have this, then it'd be looking, channel 0 and channel 1 would be separate channels. You could read two different inputs, but we're reading one input across two input pins, and we're doing it in differential mode. So this is where you set that up. So, and this initializes the MCP, and this is the variable that represents that initialization. That's like a handle. So these are the thresholds for the hysteresis raw ratios. This is for the high sensor, the low, medium sensor, and low sensor. So now it's only reading one pressure sensor, but it's going to output three different control lines going to the main controller board. These two represent what's going to happen to the top control line on port 0 on the main on the propeller microcontroller. This will go to port 1 on the microcontroller, but I mean these specify the thresholds. So when the ADC raw value gets to be this value, it disables the pump. If it's this value, that means the water's gone down. It re-enables the pump. That's what these are all about. I'm not really doing a whole lot with these in this application here. I do handle these, but I'm really only looking at these two for now. So, and these two down here, get back up here. But I'm working with a VNC viewer right now, so there's a little bit of a delay. I'm on my PC, examining what's going on the other computer. That's why there's a delay here. Okay, so this is just used for, indicating if it's been checked previously. These are the pins are going out to the propeller chip. This one represents the high switch. This one represents the middle switch. This represents the bottom switch. So basically, what's going on with this circuit? It's a pressure sensor to level sensor converter. See what I mean? Or should I say a pressure sensor to float switch output converter? Because the propeller chip thinks it's communicating with 3 float switches, but it's not. It's just receiving outputs from the Raspberry Pi, and the Raspberry Pi is fooling it because it's outputting it. This is going to be for the high level. This is the middle switch, middle float switch I'm talking about, and this is the bottom float switch. And this is where I turn all those the outputs off, starting off with them all off. Okay, and down here, this is for serial communication. I'm not doing that with this one. And this thing can also send emails. I'm not really talking about that during this video. But down, and this is where it's receiving a string, a message from the propeller chip. But right here is where I'm interested in. Okay, so a little bit of lag here. Okay, a little bit. Here we go. It keeps there, a bit more. This is a while loop right down here. Okay, first it receives that. What happens is the propeller sends these strings over, and this Raspberry Pi is only listening. It doesn't do any response or anything. There's no feedback, no flow control. It just listens. And so the propeller can send messages over. And for example, if a message is preceded, if the first letters are email in brackets, it's going to actually packet that out and send it via an email to my email address, telling me a new status. Okay, but I don't get into that right now because this would be too much info in one video. Okay, so right here, this here ADC.value, this receives a raw data from the ADC and packs it into this variable for raw ratio. Then down here, this is where I handle hysteresis. Okay, it turns high, medium, and low switches on or off based on the respective thresholds and hysteresis values. For example, let's look at this one. If the raw ratio is greater than the high ratio it's specified previously, and it's not, and this variable here is not on, then it hasn't been seen yet, then as being on, then set it to true because it's saying, okay, I've seen it now. And this one turns the pin on, going to port 0 of the propeller chip, indicating that the high level switch, the sensor is, the tank is full. That's basically what this is saying. And then it sends an email message. Sub pump disabled, tank is full, raw ratio, and it tells what the ratio is. But just the threshold, yeah, it's not actually telling me the actual one it's seeing. It could, actually, I should put that in there. And then here's where it sends the email. By the way, this listing, I have the full listing for this in a drive. I'll have a link I'll put in with this video down below. But it'll have my email information in there, but you can put your own stuff to try it out. Okay. And this one here, it turns it off. So if the ratio is less than raw ratio on the high, and it's on, and it switches on, then turn it off because it hasn't seen it. That means that yet, and then this turns it off. Then it says sub pump enabled. The tank is not full. So this one is turned back on again. So this one turns it off up here. This one turns it on, or this one turns the pump off because it's full. It disables that this here, this and this, the level switch pin. These go to port 0 on the main controller board on the propeller chip, and that's what would normally be the input from the float switch on the top. So if it's full, then if the for example, if that raw ratio is high enough, because the higher the raw ratio, the more pressure, the deeper the water. All right, so this one, oops, there's a delay. Okay, so if the raw ratio is less than the threshold, the on threshold, then turn it on. It's kind of backwards, I guess, on this, but it basically, the on threshold, meaning if it's below a certain point, turn this, and it hasn't been seen, and it's been seen previously, then turn it off. Set this to on. This one represents if the switch is on or not. So this means false. Rather than trying to read the output port, I'm just reading a variable that represents what it was last set to. All right, and then this is the other message. Now I didn't send emails with these other values here because I don't let the water get that low. And finally down here, this is going to print on the screen of the terminal at the Raspberry Pi. If you're okay, so if the reference, see, I'm using the VREF is 3.3 because the Raspberry Pi logic and the bias on the ADC is 3.3, so that's what we use for the reference. And the difference, voltage difference, we put with the 3.3 times that raw ratio. That raw ratio is a fraction of this here, of the reference. That's what's going to, that's the actual, this will be the voltage across that resistor that the ADC is seeing. And then here's where this prints it out. Okay, so now to review some of the image of what we just talked about here. Okay, right, probably this one here. Yeah, we got here, this. Okay, so on this here, there'll be 3 pins coming out from, this is at the Raspberry Pi. Well, these are inputs from this. Well, actually, some of it's output too, the clock and the MOSI going back out to this. But from the Raspberry Pi, there'll be 3 outputs going to, that represents the 3 pins going out to the propeller chip. This doesn't show that. This just shows the interface with this. But now the Raspberry Pi will also, like I say, 3 pins for the high, medium, and low, representing those values for the flow switch. Those will be going out to the propeller chip.